This is the Living Things lab, and these are the supplies you should, I'll show you the lab worksheet in a moment, you should have. And if you don't have these items and you want to just follow along while I do the lab, that's fine. But you should have chicken liver, potato, hydrogen peroxide, a knife to cut these food items, water bottles, empty water bottles, a balloon, if you have one, and a non-living thing such as a rock. I actually used a dime in this lab. So let me explain the lab. Catalase is an enzyme found in the liver and some vegetables. In the body, catalase helps to break down hydrogen peroxide when levels get too high in our bodies. Catalase breaks hydrogen peroxide into water and oxygen. So it breaks H2O2 into H2O and oxygen. Notice that no chemical reaction occurs with the rock, or in this case, the dime, and the hydrogen peroxide. The rock is a non-living thing. It doesn't have enzymes in it. So we're just going to be basically introducing ourselves to the fact that non-living things act a certain way and living things act a certain way. So basically the living things, which are the liver and the potato, are protecting themselves by breaking down hydrogen peroxide. And that's what happens in our bodies. Hi, everyone. So we're doing the chicken liver, potato, and hydrogen peroxide lab right now. And let me go ahead and explain real quickly what you're going to see happen. I'm going to be putting the chicken liver into one of the bottles, a couple pieces of potato into another bottle, and then a non-living thing in the third bottle, and that is going to be a dime. So these two items are living things, and they have an enzyme in them called catalase. So when we add the hydrogen peroxide, which is H2O2, to the catalase in the food, it's going to break the hydrogen peroxide into water and oxygen. So H2 means there are two hydrogens in the hydrogen peroxide, and O2 means there are two atoms of oxygen in the hydrogen peroxide. So what this breaks down to is two atoms of hydrogen and one atom of oxygen. Now, where did the other one go? It breaks off. So now instead of hydrogen peroxide, we have water and oxygen. But oxygen doesn't exist as just one oxygen atom. It has to link up with another oxygen atom in order for it to be in the air and for us to breathe it. So the oxygen atoms that are getting released are going to link up, and they're going to be O2, which is oxygen. So in the air, we're going to see, in the balloon, we're going to see the oxygen accumulate, hopefully, if the lab goes right. So this is the explanation of the lab. I'm going to move this, and I'm going to go ahead, and you can do this along with me. I'm going to cut up about maybe 4 pieces of the chicken liver. Doesn't it look yummy? Here's one piece. I'm going to cut up a couple more. So if we can cut it up a little bit small, there will be more surface area, and then more catalase can combine and have a chemical reaction with the hydrogen peroxide when we add it. So there's about 4. I'll cut off one more piece here. All right, so we have about 5 little chunks. Ooh, so yummy. Yuck. Of the chicken liver. Now I need a little bit of potato, so I'm going to cut this. It probably doesn't matter if you include the skins from the potato, but I'm going to try not to. Be very careful, get help from your parents. Hopefully your parents are nearby when you're doing this. All right, so I'm going to cut these in 1/8, and then I'm going to cut off some of the skins and put them in. All right, that should be enough. Actually, you know what? let's not even worry about cutting the skins because I know from experience that from watching it doesn't matter. The catalase is in the potato. All right, now we're gonna cut it small enough that it's going to fit inside your bottle, okay? So these are gonna work, I think. Cut these a little bit smaller. And I think this is enough. Okay, actually that's probably more than enough. I'm gonna go ahead and put this over here. Okay, so I'm gonna do the non-living item first, which is our dime. I'm gonna add it to the bottle, and I'm gonna add a little bit of hydrogen peroxide just to fill sort of the bottom of the cup. And what we should see is basically no chemical reaction. We won't see any fizzing. We won't see any bubbles. Pretty much see nothing happening there. All right, and I will keep this, I'll keep this sitting here so we can keep an eye on that. Now, with the potato, I'm gonna put the potato in, and I'm gonna put some hydrogen peroxide in. We should see some activity. I'm not going to put the balloon on top of the potato one to check for oxygen. I think it's gonna be a little more exciting to do that on the chicken liver one because liver has a lot of catalase. And I only had one balloon. So we're gonna do that on the chicken liver one. So next is the potato. I'm just gonna lift it up, drop it in there, sort of push them in. You can sort of pay attention to how long it takes for the enzymatic reaction to occur. All right, so we're adding our hydrogen peroxide to the enzyme. And maybe you can see some action occurring already. Hopefully you guys can see that. You'll see some white bubbles on the top. There's some white foam developing. A lot of white foam. So what's happening there is the liquid, the hydrogen peroxide, is turning into water and oxygen is being released. That's the bubbles coming up, oxygen being released. All right, so we can just kind of keep an eye on that. And now with this one, you don't have to do this exactly perfectly the way I'm going to be doing, but I'm going to put the hydrogen peroxide in the balloon. Then I'm going to attach the balloon, and then I'm going to tip it up, and when the hydrogen peroxide goes into the bottle, as I'm catching the oxygen as it's being released. So I'm not missing any of the oxygen. So I happen to have a disposable pipette. If you don't have all these things, just do the best that you can. All right, so I'm gonna put a decent amount of hydrogen peroxide in here. Oops, that one, I didn't get any. Maybe a few tablespoons, a couple tablespoons. Another way to do this would be just put it into like a measuring cup that has a spout and then just pour it in, which I might do in just a moment here if this is, oh yeah, this is taking a long time. That's a decent amount that I have in there, just a couple more. Yeah, I think that'll be good. All right, so I'm going to put my liver in here. I'm putting my balloon over the top. Trying to do this without letting the hydrogen peroxide get in there quite yet. Okay, so I'm putting the balloon over the top of the water bottle, and here we go. Now what we should possibly see, now notice the balloon is already filled up with air a little bit. We should see it fill up just a little bit more. It looks as though it's almost happening already, maybe. Let's see. Okay, so it's definitely foaming up there. The balloon is definitely filling up. Woo, that's more than I thought it would. And I'm gonna have to be careful that it doesn't pop. You see a lot of foaming action. I'm noticing that these bubbles are bigger, so there's just, it's like this chemical reaction is not wasting time with these little tiny baby bubbles. It's just making those big bubbles, releasing that oxygen, creating water and oxygen. Now, something else I've seen people do, I'm sort of afraid to do it myself, is they've had a stick of flint. They lit the flint and then shook it to put the fire out, but then the end of the flint was still glowing. They pulled the balloon off of here, stuck the glowing flint inside, and the glowing flint lit on fire again. And that's because of the oxygen being released. It's pretty concentrated oxygen. So you can see that the reaction is still going. If you want to, in your lab, you can time how long it takes before the reaction stops. That basically means that all of the hydrogen has broken up into water and oxygen, and there's just nothing left for the catalase to do anymore. Okay, so that's the lab. So you can see that chemical reactions can occur with living things, and you can still see that our non-living thing here, the dime, nothing has occurred. But we have it, this reaction looks like it's still going a little bit. This is the potato. This one, I don't know if it's still going. It doesn't seem to be fizzing too much at the bottom. And the balloon seems to be just staying the same size, so that might be done. All right, so that is our lab. Back to class.